So my only goal with this video is to have you understand object-oriented programming at the end of it. That's it. It's a lot more simple than how I feel like a lot of people make it sound. There's a lot of big words: encapsulation, abstraction, inheritance, polymorphism. Those are the four main principles of object-oriented programming. And instead of me sitting here talking about it, what I'm going to do is code it and explain how each one of these things are working as we code it. I think that's the best way to go about it. So in order to talk about those four principles, and we're going to start off with encapsulation, we first have to make a class. So I'm going to create an inventory system like you would find in a video game. And what does that inventory hold? Items. So we're going to create a Java class and we're going to call it item. So you can think of a Java class as a template or a blueprint to create new items. And every new item that you make is an object. Hence the term object-oriented programming. It's not overcomplicated. It's quite literally an object, like the phone on your desk, the cup on your desk, the sword in your inventory. Those are objects. And what do those objects need? Well, they need some attributes. So they're going to need a name. So we'll save that name as a string. And they're also going to have a quantity. Like you can have 30 apples in your inventory. So that is going to be an integer. And we went over data types and everything leading up to this point in the last video about learning Java in 15 minutes, the world's shortest Java course, whatever I named it. We didn't go over private though. So private, as opposed to public, means that they cannot be directly accessed from outside this class. In order to access them and assign values to name and assign values to quantity, which again will be different for every single item, which is why we're not assigning a value of item or anything to it right now. The way to do this is via getter methods. String get name, and we're going to return name, and then public int get quantity, and we're going to return quantity. These two methods allow you to access and modify these private protected attributes. And this right here, in this instance, these two attributes and these two methods that allow you to access and modify these private attributes is encapsulation. It keeps our details inside this class safe and provides controlled ways to access or modify it. Now, in order to be able to use all of this, remember, this is so far, it's not a complete blueprint, but the class is a blueprint. In order to create an actual object using this blueprint, we are going to create a constructor, which is not called constructor. It is a special method that you call the same as your class, and this name, this quantity. And the this keyword is just Java allowing you to have your parameters be the same name as your attributes instead of having to name it like name2, quantity2. And then you'd have to come and remove the this and then add 2 to each one of those. It's the same thing, just a much better and cleaner way to go about it. Like this. Now we're going to call this constructor, this special method, in order to create an object using this template. But first we have to create our class inventory, because inventory is what's going to be holding these items and displaying these items. So we're going to call it inventory. So in inventory, we have to store those items. So we're going to create another private field, but we're going to use something we haven't discussed before, and that is an array list. An array list of items. So an array list is a collection, which is a specialized subset of non-primitive data types. It stores and manages groups of objects, and it is predefined, as you can see up here, the automatic import in java.util.ArrayList. So Java has it built in. Now allow me to repeat part of that. It is to store and manage groups of objects. Whereas an array, for example, could store strings, it can store integers, but it cannot store objects. Whereas the array list can restore objects and is also dynamically resizable, whereas arrays by definition are fixed. Even though in JavaScript and other languages they're not fixed, they are resizable. In Java they're fixed, they don't store objects, so we have to use an array list to store our items objects. Now what I have to do is create the constructor for inventory. Whereas we don't have any parameters that we're passing through. We're just creating a new array list called items. And just to clarify that statement, this is where we are creating or declaring the array list called items of item, or in other words, item objects. And within our inventory constructor, we are assigning a value of new empty array list to that array list of items, because we're going to use a method to add items to this items array list. And we do that with public void add item, items, add item. But the way this works is that when you use this method, you're passing in a parameter of item, which we're going to create over here in just a second. And then that is going to be added to this items array list that we created. Or in other words, this method is adding the item into the inventory. But also we want to be able to display that inventory. We also want to remove item, but I'm not going to do that right now. We want to display inventory. We're going to use a for loop for this. Item, system out println item. And I could make this a little bit neater. Hold on. So this is how I make it prettier. We're going to have item print out and then the name of the item and then the quantity print out and then the actual quantity of the item. Oh, all right. Now that we have our inventory class and with our private attributes and then our public methods, that is encapsulation, allowing us to have access to these private attributes. And then we have our constructor right here that allows us to use this class template in order to create a new inventory object, as well as the same thing over in item. Well, how about we create those? So we're going to start off with creating inventory. And we're going to call it inventory equals new inventory. That may be a little confusing because everything has the same name, but think of it just like string equals string, just like this. So what's happening is that we're creating an inventory object called inventory. Just like here, we're creating a string called string, which we're assigning the value of string, which we're assigning the value of an empty inventory object, with this inventory right here being the constructor. And by the way, if you don't know how to drill in, you just control click and it'll take you to exactly what it is. And then this inventory over here is this class, this entire class. So then we're going to do the same thing with item. So we're going to call item. We're going to call this item 1 because we're going to create 2 items. New item, and we're going to call this item apples, and we're going to give it a quantity of 20. We have 20 apples, and then we're going to do item 2, but instead of apples, we're going to make it a sword. And instead of 20, we're going to make it 2 because we're dual wielding these suckers. We have 2 swords, well, in our inventory, not in our hands. Well, actually, that's not true. We have to add these items, these new objects that we just created, into our inventory. And the way to do that is add item 1 to inventory, add item 2 to inventory, and then we want to display said inventory with our display inventory method. And what should happen is that, well, we should be displaying these 2 pieces of inventory right here. Item apples, quantity 20, item sword, quantity 2. And if you recall, that is exactly the format that we have over here in our for loop. Item apples, quantity 20. Now let's hop into inheritance. So we're going to create a new class, and that is going to be called, let's go with fruit. So fruit for this instance is going to be a very basic example, and then we're going to do weapons after this so you can see just how fruit and weapons differ from each other, but also are similar because they have the same attributes as item. That'll make it all makes sense in a second. So the way we do this is that fruit extends item. Item is the superclass, fruit is the subclass to item, and it inherits the attributes and any other methods that are in this class item as its own. So we don't have to come in here, what is it, string name, string quantity. We don't have to come in here. We know that the fruit has a name and a quantity, right? We don't have to come in here and do string name and private int quantity. We don't have to do this because we are already inheriting that. What we do is actually give it specific attributes like type. Is it a banana? Is it an apple? Is it an orange? So then we're going to create the constructor of fruit so we can initialize the fruit. We're going to give it string type because that's the attribute that we have up here, but we're also going to give it the same exact attributes that we are inheriting from item. So what is that? Quantity. And this super name quantity right here is actually how you assign the values being passed in as parameters over here from your superclass. So instead of doing this name equals name, this quantity equals quantity, because it is in your superclass. Remember, item is the superclass to fruit, fruit being the subclass, and item containing these attributes. This is just how you do it. So now let's use this template in our constructor to initialize a new object of fruit. So item, we don't need this. Let's just do one item. We already have something for fruit, so let's call this generic item just to kind of get things out of the way there. And we're going to create an instance of fruit called fruit equals new fruit. And the first deal is a type, I believe. Yes, it is. So what type of apple should we do? These are the types I'm thinking of. I don't see a Granny Smith up here. Let's go with a Fuji. So the type is a Fuji. The name, I believe, is next, and that is apple. And we're going to have a quantity of 20 Fuji apples. And since we changed the name up here, as you can see, it's not being used, so we have to make that right. And instead of add item 2, we're going to add item fruit. So now inventory should have generic item 10 and then fruit, Fuji apple 20 when we run it. And there we have it. Item generic item 10, item apple quantity 20. Oh, we are not printing out the correct stuff over in inventory now, are we? And the reason being is that I wanted to have polymorphism be its own lesson, so I didn't do it along the way here. So do I do polymorphism now or do I do the weapon now? Let me do the weapon and then we'll do polymorphism, and then we'll be able to print things out properly and display inventory by using override. We'll get to that in a second though. So let's create Java class weapon. And a lot of this is going to be exactly, all of this should be exactly what we just saw. We're going to have its own unique attributes. We're going to have damage. And method is also going to have a type. So I guess in a way we could have put that into item.java as opposed to in each individual weapon and fruit, but that's okay. We're going to create the constructor weapon. And I'm going to do this in a little bit different order. I'd like to have the name first and then the quantity second, and then we'll add in damage. And then string type. So then the type there, which also makes me want to come through here and move string type here to the back, which means I also have to move this type here to the back. Sorry. Okay, perfect. And before I do it, take a guess. What do we need to do to pull in the attributes that we are inheriting from item? That's right. Super. Great answer, guys. And then we are going to do this dot damage equals damage, and then this dot type equals type. We're going to have get damage, return damage, and then we'll have public string get type. Wonderful. And there we go. So now that's weapon. We've created the fruit. I've showed you how inheritance works by extending attributes and methods from the superclass. Also note you can create subclasses, so specific types of weapon that extends weapons, and then weapon extends item. So you get the attributes and methods from all of the superclasses above you. Now let's hop into polymorphism. And this is just a single aspect of it. As you see over in inventory, we have item and then item.getName, quantity, item.getQuantity, and it's going directly into our item class. However, what we need to do is also have inventory. Let me show you over here. Inventory.display inventory, display the subclasses of item. So what we'll do is actually use toString. So I don't know if you noticed earlier. Let me see if I can get it to do it again. When I was typing out item here, it recommended to do item.toString. And toString is actually a built-in method to Java for objects. It returns a string representation of the object. And the only reason I'm mentioning this is because of the sentence, it is recommended that all subclasses override this method. Overriding and overloading are elements of polymorphism. So what we would have to do is come in here. We're going to tag this with override, public string toString, and then we're going to return what we want, which is effectively almost what this used to be. Not quite, but what it used to be. And I'm also just going to change this to item toString for the record, because that's what we want. Whereas in here, so we don't need all of this. We just have name and we just have quantity. Since we have name and quantity in here already, they're not the methods, just the attributes, and there we go. So now when I come over to main, because we already changed this to item toString, because we have all of the other information right here in toString, we run it, we should get our inventory. And there it is. And that is overriding. So we overrode the built-in toString, and now we're going to override this item toString in fruit and in weapon. So the toString in fruit will output the fruit name, the quantity, and the type, and in weapon will return the weapon, quantity, damage, and type. So now over in main.java, we can actually do this, and I'm going to do it with the weapon as well. Weapon equals new weapon. What do we want this to be? We want this to be a sword. I think that would be cool. Let's say we have 2 swords. We're dual wielding this sucker. The damage is 75, and we have no context. That could be really good or really bad, and it is a melee weapon. And of course we have 2 inventory, add item, weapon, and then display inventory right here should display all of this inventory in all of the specific fields. So there we go. So this down here, yeah, it is just one concept of polymorphism. And I should really clarify, because technically what we've discussed with overriding is an example of runtime polymorphism, which is dynamic. And overriding things like this is how you achieve that type of polymorphism, which allows a method to behave differently based on the object that invokes it. So this method acts differently if item object invokes it, and toString being the same method acts differently than that because it returns something different when the fruit object invokes it, and then weapon even different than that, even though it is accessed through a reference of the superclass. And I guess to clarify even further, it's called runtime polymorphism as opposed to compile time polymorphism, which we'll talk about in a second with overloading. Runtime polymorphism occurs when a call to an overridden method is resolved at runtime rather than compile time. So when you override, this is happening at runtime. When you overload, that is happening at compile time. So to call back to my last video about Learn Java in 15 Minutes, World's Shortest Java Course, when you compile the program, you are creating bytecode in these .class files. And then your .class file goes to the JVM and runs in order to get all of our expected output like this. Compile time, runtime. So now let's implement overloading. And I think we have a good opportunity to do this in our inventory class. And the idea is that you have multiple methods with the same name that take different parameters and can do different things, basically. So where did we call this? You remember we called this over in main Java when we want to add item to inventory, whereas item contains this information right here. And actually what I'm about to do, I think it makes the code worse, basically. So I didn't find a really good example for overloading, for polymorphism overloading in this code base, but bear with me here. We're just going to use this as an example. And over in inventory, we're going to create public void add item. Remember, we are overloading this method to do other things than just items add item. Okay? Take a shot every time I say item. I'm just kidding. I don't want you to die. So you want to add in all of the parameters for fruit, because right now what we're doing is we are bypassing the need, because right now it is a need, the need to store all of this information into a fruit object here, and instead we will call it all directly in add item, which if you saw my last video, you know that I don't like doing it this way. It's typically not good. I like to store it in something and then I can reuse this as much as possible. But again, overloaded example, not best practice example. Let's move that over. Perfect. It was a weird word. It was a weird wrap over here. You know what I mean? I don't like that there. It's ugly. So boom. And then I'm going to do exactly what this does, but with this. So items, come on, autocomplete, come in handy, please. We're going to create new fruit, and then we're going to do name, quantity, type. Perfect. We can also do this with weapon, actually, because we have 2 subclasses for it. Add item. Yeah, I'm not going to make you watch me type all that, but also the word wrap is still annoying. Whatever. Anyway, what you may notice is that this add item is being used, and these add items are grayed out. They are not being used because when we are using it here, we are only passing in 1 parameter. However, if we change it to fit the format as this add item and this add item, then it'll know which add item we are talking about and it'll use that specific method. So over here, let's do it. Instead of this fruit right here, let me just comment this out. Instead of that fruit, instead of that weapon, what I'm going to do is actually, I'm just going to copy and paste because that makes my life easy. Copy. There we go. And what should occur is that we have the same exact output as we had before. Boom. Because we are adding the same exact thing as before, just in a different way. In my opinion, worse way. We are doing new fruit here, whereas before we did it right here. And then we are giving the values right here in the add item, which are then being passed in as parameters right here and back into here in order to add this object fruit into items, into inventory. Huh, that's interesting. It doesn't show as blue even though it's obviously being used. That's weird. Anyway, I could also do the same thing with display inventory, like this right here. What I'm doing is I'm only displaying items by type. So if I come over here and I do exactly like this, and I pass in the parameter a specific type, which is Fuji in this instance, is it'll display that specific fruit with that specific type. And I mean, this is pretty obvious, but if I type in melee, which is also a type, it'll display that as well. And that is method overloading, which again allows multiple methods in the same class to have the same name, but with different parameters. And this is how you achieve compile time polymorphism, or in other words, static polymorphism, method overloading, as well as operator overloading. And why would we want to do something like this? Well, one, it makes it easier to read. I mean, at least for me it does. Compile time polymorphism with overloading allows for, well, errors to be caught in compile time as opposed to runtime, because this doesn't run in runtime. If we want to use this one or this one or this one, all of that is done and decided in compile time, no additional checks during runtime. So it also increases performance. Whereas back to overriding does run at runtime. It performs runtime polymorphism, and that is when you want something to be more dynamic, more flexible. And it also allows you to reuse these methods in whichever way you see fit. Polymorphism. Oh yeah, and just to clarify, these overridden methods, as well as the overloading of methods, while are both ways to achieve polymorphism, they are also a part of encapsulation, because encapsulation is all about bundling the data, being the attributes, as well as the methods, with toString being a method, into a single unit, that single unit being item. All right, so I did encapsulation, I did inheritance, I did polymorphism. Oh crap, I didn't do abstraction. So abstraction, on like a broad stroke, the broad definition of abstraction is the concept of hiding complex implementation details and showing only the essential features of an object, which as a programmer, when you implement it, it helps to reduce complexity and allows you to focus on interactions at a higher level. And there are a few ways to implement it. You can use abstract for a class, you can use abstract for a method, and we'll get to that in a second. Let's start with abstract for a class, and let's do class item. And what this does, it means that we can no longer use class item to create an object. You'd be like, why would we want to do that? Well, do we really want generic item over here? Or do we only want to be able to create the specific subclasses of item? We want to do the latter, so we're going to make item abstract, which is why this is yelling at us, by the way, because it's saying, hey, that's abstract, you can't do that. So I'm going to comment that out. Okay. And that also means that we actually don't need this override method at all. We need it in our weapon and in our fruit, but we don't need the toString method here because there are going to be no specific item objects, only the subclasses of item objects, and we can create an abstract method right here actually. Let me do public abstract, void display info, boom. Wait a second, this is a method. Aren't there supposed to be parentheses and then you return something? Or at least do something, like over in here you're adding item to item? Well, that's the point of an abstract method, is that you're not doing anything right here other than making the subclasses implement display info, which means we would override it, void display info, like that. But of course we'd have to put this into a system out println just because that's proper formatting, and that's why it's no longer yelling at us and why fruit is yelling at us, because we aren't using display info in fruit, even though it's required based on this abstract class item. And instead of void and changing all of this to system out println, we could have kept it string, make this string. And when I say kept it string, I mean like toString was string, and then we would return like this. And we could have done it just like this. It just depends on your use case. This is better when you want to give the caller the flexibility to decide how to use this information. You want to console log it, you want to add it to the UI, you want to system out println, you can do whatever you want. However, if you want to be more strict, that's when you would do something like void, because now we are forcing it to do system out println, which encapsulates the display behavior within the class. And then of course over in inventory, instead of displaying item to string, you would want to do, actually, since we're already doing system out println within display info, all you do is item.display info, and well, that's how you display inventory now. However, there's also another part of abstraction, and that is an interface. So with an abstract class like this, you're able to have your private attributes right here. You're able to have a constructor. You're able to have concrete methods, so just public regular methods, and you're also able to have abstract methods. However, an interface is a little bit different. If we want to come over here and do new, I guess Java class interface, there we go. And we'll call this item stuff. Maybe we would change the item class, abstract class, to an interface, but for this example, we're just going to call this item stuff and create a new Java file. And within the interface, you're going to have common methods that all items must implement. So get name, get quantity, and display info. As you notice, these are the same methods that we actually have over here. Get name, get quantity, display info. And you also may notice that we do not have the abstract keyword right here. That is because everything in an interface is assumed to be abstract. We don't have a constructor like here. We don't have all of these attributes like here. All we have are methods that must be overridden. So over in fruit, if we want to do it here, instead of extending item, because that is a class, abstract or not, that's how you do it, you would actually implement item stuff. That is because it's not inheriting anything. What it's doing is it is forcing fruit to implement everything that item stuff has, which are actually what we have over here. So actually we already have display info. I'm just going to copy and paste to make my life easy. And then we have to add the attributes in here. Private int quantity, private string name. I did that out of order. That's better. And also, since we are not inheriting it, we have to do this the old-fashioned way. And there we are. We have everything that we need from item stuff, the stuff that it's making us do, but we have to add all of those methods and overwrite. All of these are overriding, not that one, but all of these are overriding. There we go. That makes more sense. They're overriding this right here. And we're also declaring all of our private attributes in here. And then if we do this to weapon, we would have to do the same exact thing for every single one that implements item stuff, as opposed to having the common attributes in here and the common methods in here as well. So why in the world would we want to do an interface where we have to rewrite all of this code every single time, as opposed to having a class and just doing it once? And then if we need anything abstract, we could just do an abstract method and an abstract class. Well, one interesting note is that when you implement things, you can implement as many as you want. You would just do implement item other stuff, pretend that that is an interface that we actually have, and you can do this as many times as you want. You could also do fruit extends item and implements item stuff. So that's an interesting point. But also, if it doesn't have a clear hierarchical, that's a difficult word, a hierarchical relationship. So like a weapon and a fruit is an item, but what if I had something else that wasn't an item, but I also wanted it to have item stuff? Then I could have a weapon implement, or let's go with fruit since it's already there, a fruit implement item stuff, as well as a horse. A horse is not going to be something that you keep in your inventory, I don't think. So let's pretend it's not, but let's pretend you also want the horse to have a get name, get quantity, and then display info. You would implement item stuff so that it forces that horse to have these methods. So that, I hope that helped. That's abstraction. So now try to go build something yourself. Because if all you're doing is watching videos like this and watching the perfect way to do it, instead of going through trial and error yourself and messing things up and then trying to figure out how to fix the things that you messed up and going like this until you finally get to the proper way to do it, well, you're not going to learn. So this is your call to action. Right after, well, call to action, like the video, subscribe to the channel, turn on the notification bell. But here's your call to action to start coding. Maybe you were following along coding this. If so, awesome. Now dive into the code and change things, manipulate things, try new things, break it, fix it, break it again, fix it again. That's how you learn. Hope you enjoyed it. There's so much more to Java that I can also discuss maybe in a future video. Y'all just let me know. Okay, y'all have a good one.